Come on.
So only 2 lessons are we left.
Yeah, for this chapter. Okay. Did it open yet? It'll open now. So I was saying to Andy, about the essay you'll have to write.
Nice.
So you'll start looking at how to write a physics essay in ESAP this week. Once I make the lesson for it. I don't know. I don't think it's too bad. I don't think it's going to be as difficult as your chemistry essay, because it's not. I don't think it's as long, and it's a little bit easier to talk about physics and chemistry.
So like how you would talk, because like it's first time to talk about to do and summary of physics.
I know it's the first time to do it, and it's worth 10%. So.
Okay, so yeah. Yes.
But yeah, I'll be here. I'll be here, and the SAP will be here to check as you're working on it.
Okay, so we'll be having 3 chances. Like we'll send you and you will correct it.
No. Reduce that, not 3. Less than 3.
2.5.
Less than this.
1.5.
Less than
What?
Submit and finish. That's it. That's it.
So no draft, nothing.
No, but that's because you're thinking it's negotiation. It's not. That's because in class I give you some time to show me what you've written and give you feedback on it.
That's fine.
But how long do we have?
Well, I haven't even set it yet, and when I do set it, you'll have 2 weeks. So this is all just kind of pre-talking about it. It hasn't been set yet. No, after the break.
I mean 2 weeks for doing it?
Yeah.
And what about how many words? 1,000?
I have to double check. I think it's 1,000.
Why?
But
We are humans.
yeah, but I'm trying to make you into men. No, come on. I'm trying my best, okay? Alright, write this down now.
Good one.
Yeah. Write this down. Come on. True. Yeah, true. Yeah, true. Alright, circular motion, so. Did you write this down?
Yeah.
Circular motion, okay. Right, so a little bit of maths before we start. Okay. So, let's see if you know your parts of the circle.
So,
yeah?
Okay. Can
No.
I say?
Is it a question? You know the names?
No, yeah, I know one of them.
Which one?
The arc.
What is it?
Radius.
Radius, very good. Hey, come on, you're all finished. Good timing, we just started the next lesson. So you only missed the homework.
Oh my god.
Yeah. How was the talk? How was the talk?
They introduced some of it in this.
Yeah? This is all you got was a card. Okay. Right, yes, the ore is... Flung, this is actually the first slide. Okay. What's the ore called? You said radius.
Yes.
Well, we should know what the theta is called. The angle.
Yeah.
Now, what about the S?
It's the distance between.
Now, there's a special word for it.
Significant something.
It actually doesn't start with S. Yeah.
What is
The reason it's an S is because it's a distance.
Oh.
No, actually, what you're thinking of is circumference, and that's the whole thing.
Circumradius.
Circumference is the whole thing.
Circumradius.
No, I don't think so. No, I'll give you the names here. So, yes, the first one is the radius, and then this here is the angle, and then here the S is. Anyone want to try? Begins with an
I
A.
want to remember what's the S.
Angular line.
Arc length.
Arc.
Yeah. Yes.
The S is the arc?
The arc, yeah. Well, to give it its full title, it's arc length. I'll just say arc. And the reason it's an S is because it is like a distance. Yeah.
But in a circle.
Yeah. So this is the S. The angle is a theta, and the radius is r.
What do we call the full?
The full one, the full arc is circumference. Oh, diameter. Diameter, yeah. Okay, do you have these names?
Yeah.
Yep, okay. So, the circle, no less. Theta is the angle, r is the radius, and s is the arc length. Okay, you have all of that?
Q.
This?
Yeah.
I see, you don't like this. See, it's a theta, and I think you prefer an alpha.
Yeah.
Yeah, it's not a Q. Yeah.
I prefer theta.
Sit forward. Okay. Right. So in physics, when we're dealing with motion in a circle, we do not use degrees. We use a new unit known as the radian. So, you know for a circle, one full turn is 360 degrees. Yeah. Now we don't use this unit in physics.
Yes.
Yeah. We use a different unit called the radian. And you will study more about this in detail in maths class. But for us, we're just calling it a new unit. Now, the definition of the radian, or rad for short, is defined as, now this, okay, just to be clear, this is the physics definition that I'll just use for class. There's a more technical definition in maths. So for physics, we can just think of a radian as being 57.3 degrees.
Okay.
The reason why this unit is important will be explained in the math class. And if you're wondering, the 57.3 is in fact exactly 180 divided by pi. For physics, it is important because the formulas we will use only work when the angles are measured in radians. Now you don't need to write all of this down. This is the key. And maybe you want to write this down. The 180 over pi is the exact value of this.
And what about 1 degree is equal to?
Yeah, we'll do the conversions and all of that, yeah.
I think 1.73.
No, we'll see, don't worry. So, just to be super clear, 1 radiant equals 180 over pi degrees, which is roughly 57.3 degrees. Yeah? Okay. Does anybody know why radians are important? Like I said here, the formulas I'm going to show you, you need to use radians. Does anyone know why radians is important?
I think for the circle,
Yeah, what about the circle?
it's
You know the size
not
or
an angle.
Anybody?
the
Using
the angle or the size.
I'll tell you. Look, I'll tell you. If this is in radians, this angle, and only if it's in radians, you can know that the arc is equal to the radius multiplied by the angle. But that only works in radians. So for example, if this angle here is 1 radian, and this here is 2 meters, then I know this arc will be 2 meters. And if this was 2 radians, how big will the arc be? 4 meters. Now we'll do these formulas in a little bit, but the reason they're important is for these formulas. Yes, indeed. Alright, continue. Yeah, you have this? Yeah? Okay, so let's just do some conversions to start with. I'll let you try it and then I'll do it. Convert 0.25 radians into degrees and 30 degrees into radians. Try this, please. Using the definition I gave you, this is enough to convert it. Okay. Do you have this?
Yes.
Yeah, so the first one is 0.25 radians. Well, that one's the easy one because 0.25 radians equals 0.25 times, if I do it exactly, 180 over pi degrees, because remember 1 radian equals 180 over pi degrees. So let me see what I get. What did you get?
14 point.
Yep, it'll be 14.3 degrees. Now part B, 30 degrees, was it?
Yeah.
30 degrees. Okay, so what you can do is you can go backwards here. You can say pi over 180 radians equals 1 degree by cross multiplying. So this will equal 30 times pi over 180 radians. Which equals 0.524 radians.
Could you go back to the question, please?
Yeah, I think it was 30 degrees, wasn't it?
Yeah, it was 30 degrees.
Yeah.
30 degrees means this rate. So if it's degrees, what do we do again?
Yeah, I took my definition up here and I just rewrote it so I have 1 degree on the right. So in other words, it's like I made a new definition. 1 degree is equal to pi over 180 radians. Yeah?
Can I say 1 degree equal pi over 100? 1 radian equal 1.85. 0.5 radian equal x, and multiply it like this.
Oh, like solve it. Yeah. That's fine, yeah. Continue? Yeah, okay, so we have seen 2 types of motion so far in physics. The SUVAT motion in 1 dimension, and then, like a car, and then the SUVAT motion in 2 dimensions, like projectiles. Yeah, so we have 2 types of motion. Motion like this, and then motion like this. So now we'll look at a new type of motion in 2 dimensions, motion in a circle. So firstly, what makes motion in a circle? So, does anybody know what makes something move in a circle?
Like something.
Does anybody know? So like here's the car, and it's moving in a circle.
Flat, maybe?
Yeah, but what
Constant speed.
true, but what's happening is there's a force. So is the force this way? You might think it's this way, but it's not.
It's like this way.
You think it's like maybe a bit at an angle like
No,
this.
it's the opposite.
What, like this way?
Yeah.
But then
maybe-
the car would go over here, wouldn't it?
No, but
Or maybe
I
the
would be
other way.
thinking,
The force is same, like coming and going, coming and going.
Why is it not this way then?
Why is it not what, this way?
Yeah.
Oh, I think
No.
it's in a circle. The
Or
force
maybe
is in a
the
circle.
other
In
way.
the middle.
Or the like the way that the arrow going the
Go
the
this
arrow-
way?
Yes.
No, the circle is in the center. The force is in the center.
Yeah. So, what's happening, believe it or not, if something is moving in a circle, there's a force or an acceleration towards the center. This is what makes something move in a circle. So, if an object is in circular motion, then there's a force acting on the object. It's perpendicular to the velocity, and it's directed towards the center. So I'll just draw that before you write it down. Just look here 1 sec, please. Here's the car. So here you have, this is the V, and then this is the F. By the way, where's the A? Which way is the A?
In the direction of force?
Yeah, because remember F equals ma.
Yeah.
So for example, if we had 1 kilogram, then F equals A. So you can see that the F and the A are nearly the same thing. They only differ by m. So basically, if the F is here, then the A is here as well. These are perpendicular. This goes towards the center, and this runs along perpendicular to this.
So why doesn't the car just go to the force is to the...
If the car is going fast enough, then it will maintain motion in a circle. If the car was at rest, and it only had this force, then it will go towards the center. But it's because it's moving is what keeps it in a circle. It's a bit like, imagine the car is going really fast this way, and then a force suddenly moves it to the left. The car won't suddenly move to the left. What will happen is it will get shifted into moving into a circle. If the force becomes really big, if the force is big enough, then it will spiral into the center. If the force is too small, it won't move in a circle, it will just curve slightly. Yeah?
Can you relate it to real life? Force of the car?
Yeah. Do you ever drive around a roundabout?
Yeah.
Yeah. And how often do you go to the center of the roundabout when you drive around it? Never. Yeah. Because you, when driving, balance the force with the speed of the car so that you don't move in or out. Do you know?
So if I was slow, I'm going to move in?
If you were moving slow and you kept the same force, then you will move towards the center. Which makes sense if you think about it. If you're moving to a roundabout and you enter the roundabout and you are going slow, but you still turn the wheel the same way as if you were going fast, you'll go to the center. And if you're going to the roundabout and you turn the wheel the same way, but you're going too fast, what will happen? Well, you'll fly off the roundabout, yeah. When you turn the wheel, you're putting the force towards the center.
Okay.
So imagine you're driving around the roundabout and you turn the wheel, a bit to the left. You do the same thing at the next roundabout, but you're not going as fast. You can imagine that you'll move to the center of the roundabout. Have you driven around a roundabout before?
No.
Well, then this is why you don't get it.
Or there is a game like in which the car is moving in a circle. The one what we call
the racing track.
No. They play a game when you go to some circus.
Oh yeah. Usually a motorbike.
The death hole, they call it.
A cage of death or something like this. Yeah.
Because they're going fast, that's why they can.
Yeah.
Yeah, that's okay, I understand.
It's the same.
If they went slow, they
They'll fall down.
Yeah.
And they'll fall to the center.
Yeah.
And if they're going too fast, then they'll move out.
Yeah, they go out. They are
Yeah.
always at the corner, famous.
The F and the V have to be balanced a certain way. If the F is too big, it will spiral into the center. If the F is too small, it will just simply curve a little bit. It's not just because there's an F here doesn't automatically mean it'll move in a circle. There does have to be a relationship between the F and the V. Yeah, it doesn't just happen automatically because there's an F there. Right, so the formal definition which you will need for the exam is this. If an object is undergoing circular motion, then the net force acting on the object is perpendicular to the velocity and is directed towards the center of the circle. Oh, I already drew it. Nice. Okay. You have this?
Yeah.
Yeah. Yeah. Too long? Yeah. Okay. That's Andy. Yeah. Okay. So just a little bit of definition. You see this force here? This force has a special name if it makes something move in a circle. We call this force centripetal or centripetal, whichever way you prefer to say it. Centripetal? Yeah. Centripetal force is a type of force that makes the body revolve around the center. So it's just a special name for this force. We call this force centripetal force. This force keeps it moving in a circle.
Do you have to write?
Yeah. But you don't need to remember this for the exam. You just need to remember that centripetal force is the name for this force.
Yeah, but we have to write.
Yeah. It's good for your English.
So we should also write this force contributes to keeping the body in flow.
It's good. It'll help you remember this. You have this?
Yes.
Do you?
Yes.
Okay.
I have the idea.
Oh, no. That's different.
There is a dome.
Okay. So, but F equals ma, as you know. In fact, for example, if m was equal to 1 kilogram, then we would have exactly F equals a. So basically my point is, the following should not surprise you. Centripetal acceleration is a type of acceleration that acts on a body that revolves around a center. Circular motion. This acceleration contributes to keeping the body in circular motion. This acceleration is always directed towards the center. Now look, wait, stop! You don't need to write it again. It's exactly the same thing, isn't it?
Yeah.
Except I replaced the word force with acceleration. So you can almost just, if you want to make a little arrow on your definition, you can write force or acceleration.
I'll write force because it's easier.
Now, but I need you to write this down.
Which one?
Both. But you can just make a little arrow. So here, force, you can just put a little arrow saying acceleration.
Like I write the down one at the same.
I just said no. Don't write this down. Just write this down.
Yes.
But
All of it. Yes.
put a little arrow here
Yes.
above force and say or acceleration.
Oh, okay.
So that should only take you a few seconds. So when I say centripetal force or centripetal acceleration, it means the force or the acceleration towards the center of the circular motion. Okay. Now on to some more definitions. Angular velocity. So let me just explain this with an example. Here is the car, and then here it is 1 second later, and this is 1 radian. Here is the car, and here it is 1 second later, and this is 2 radians. So which car is going faster? The first or the second?
The second.
The second, of course. Because here, in 1 second, the angle changed by 1 radian. But here, in 1 second, the angle changed by 2 radians. So this one is like 1 radian per second, and this one would be 2 radians per second. This is called the angular velocity, omega. The angular velocity, omega, is the change in the angle with respect to time. And the units are, of course, radians per second.
So its formula will be angle upon time.
Change in the angle over the change in time. Okay. You have this? Yeah. So this measures how quickly the angle is changing. For example, 1 radian per second, that is 1 radian per second, means that the angle increases 57.3 degrees per second. Right, next one. What does it? Maybe somebody might know this one. The periodic time.
The continuous time, like
Yeah.
the time change in interval.
No.
The distance,
No. Does anyone know this one?
the speed,
Periodic time?
no.
This is the time for 1 revolution. The time it takes to go around once. So the periodic time is the time taken for 1 orbit to be complete. Of course, the units are seconds. What is the periodic time for Earth?
Forward.
Earth.
It's
The place where you live.
24.
No? Well, around the sun.
365.
365 days. Periodic time for the moon?
Well, same.
no.
So around the sun.
Around the Earth.
It's
20.
1
1 million or something like that.
No.
132.
I believe there might be some Islamic students in the class, correct? Right?
1 month.
And
1 month.
that's it, yes,
1 month.
yes, because in your calendar, 1 month is 1 orbit of the moon around the Earth. Yes? Yes, which is how many days roughly?
29.
About this, yes. I am shocked that I have to tell you this. Okay. So 1 month.
Well.
Yes. Okay, and of course you have other things too, like for a race or whatever, cars driving around the roundabout, things like this. So, for example, if the time is 2 seconds, then it takes 2 seconds for 1 complete 1 orbit. Okay. Do you have this? Yeah. The units per second actually have a special name in physics. It's often called a hertz. That is, 1 hertz equals 1 per second. So, whenever you see per second, that's also the same as a hertz. Yeah. So it's not anything special. Just 1 hertz is 1 per second. This is called, oh well, we'll get to this in a second. You might have seen this unit somewhere before.
Yes, and the battery.
The battery,
And the radio?
the radio,
Frequency, when we are taking the frequency.
yeah, like the radio would be 1. TV screen,
Something like that.
yeah. Refresh rate of the TV screen, laptop screen, no? Okay, doesn't matter. So, the frequency f is the number of orbits in 1 second. And the unit, of course, is per second. So, for example, here, if I just draw this really quickly, can you look? If this car goes around 1, 2, 3 times in 1 second, do you see that? 1, 2, 3 in 1 second. We say the frequency is 3 per second or 3 hertz. Yeah. So the frequency is the number of orbits in 1 second. The unit is per second. So if f equals 2, then 2 orbits are done in a second. Yeah? Okay. What about if f equals 0.5? What would that mean?
There's no speed.
What would it be?
Half orbit.
Half an orbit in a second. So if f is 0.5, then only half an orbit is complete in 1 second. Okay. Now, after all of this, we now have enough language to look at the formulas. Okay? So, just like with U, V, A, T, S, we also have some formulas for circular motion. So, the first formula relates the T and the F. We can say that the time is equal to 1 over F. Or likewise, F equals 1 over T. This is our first formula. Did you get this? Yeah. Next formula. This is the angular velocity is equal to 2 pi over T. It's the second formula. Yeah. The third formula is a way to calculate the V. The V equals omega R. Yeah. And then the acceleration is v squared over r. That's formula 4. And then that's it. That's 4 formulas here. I need to talk a little bit about the units first. Okay. Now, let's take for example formula 3. So we have V equals omega R. Now what's the units for V? Meters per second. And omega?
Omega is
Radians per second. And the radius?
Radius per second.
Meters.
Meters per second.
Are these the same? Not quite. There's a problem. We don't really want this here. Now this is an important, well, not too difficult idea, but in fact the radians is actually not really a unit. It's unit free. So radians, I don't want to say they don't exist, because obviously they do exist, but the radians aren't really a unit. So for example, I could say x equals 20 degrees. The degrees is a unit. I could say x equals 2 radians. But I could also say x equals 2. And these are actually the same. In other words, the radiant, not actually something we have to write down. If I wrote down theta equals 2, then I don't mean this. This means radians automatically. So the radians unit free. So in other words, it doesn't matter if you use meters, kilogram, miles. It doesn't change this. Okay. So don't worry that the units don't match. They actually do match. The radiant is unit free. Or, well, I shouldn't say unit free. It is a unit. I should really say dimension free. Yeah. The radiant is no dimension free. It doesn't measure any dimension. Okay. So more importantly, let's have a look at some questions. I'll see if you can do this one, if you can figure it out. It doesn't actually need these formulas really. A CD spins at 500 RPM. What's RPM?
Rotation per minute.
Rotations per minute. Yeah. See if you can find the omega here. Try this. You know a CD, don't you? No? You're too young to know what a CD is?
Yeah, I know it.
You know a CD, okay, good, yeah.
This is 500.
No.
1.
No, you get that's for no.
I got 8.3, I think.
I don't know.
Let's have a look.
Like this?
Let's have a look. So it spins 500 times per minute. So that is 8.33 times per second. So the frequency equals 8.33 hertz. Yeah? So what's the time? 1 over f, which is 0.12 seconds. And don't forget, I gave you this formula, T equals 2 pi over omega. So omega is 2 pi over T. So we get 52.4 radians per second is the answer. Yes, what's confusing you?
We got the frequency first.
Yep.
And we got the time.
Yep.
And then we got, okay.
Can we copy?
Oh yes, definitely.
I have a question.
Yeah.
In the exam, has there ever been like a trick question where they give you the angle in radians instead of degree and it doesn't show like a unit?
If they don't show a unit, then it's automatically radians.
But if there is a degree,
Then it, yeah.
Look for it.
Yes. And this
they will.
happens, but that's more something that happens in maths than physics actually. So in the maths exam, sometimes you have to read the question carefully to make sure you know which unit you're dealing with.
Do we get marks deducted because of the spelling?
For what? Physics?
Physics.
As long as I can know what word it is you're saying, no.
chemistry.
It's not computer-based test, is it?
I think it might be. For the physics, after the break.
Either way, the final test.
Oh no, the final, no. The final one will be a handwritten test.
The midterm is.
I might make it computer-based.
But it's not graded. It's not in.
No, it's not in your report, so to speak. Yeah. Okay.
So chemistry.
So that say,
I don't know.
the
Don't know and don't care. Yeah.
the essay of physics could be counted or no?
Yes.
Like the
10%.
The after break.
Yes. 10%. Okay, do you have this? Yep. Okay. Let's have a look at the next one. Right, so I'll do it, but you can draw or write this. A car takes 5 seconds to drive around a roundabout of radius 6 meters. How fast is the car traveling? That is, what is its, oh my goodness, apostrophe in the ITS, disgraceful. I should delete that later. Alright. Okay, so you can draw or write this. No, I have to resave it, so don't worry. I'll fix it next time. Alright, did you draw this? So do you know what a roundabout is?
No.
Yeah.
Do you know, Fallon? No?
No.
I'll have to draw it for you. It's going to be beautiful.
Oh.
Okay, here's the car, and then it goes. Oh, it is, isn't it?
The best sound.
Oh, yes. And its car comes along, and then it goes around, he turns back. Okay. So, Fallon, this is a roundabout. Can you understand my picture? Yes? Oh, great. Many of them in Ireland, of course. Many of them.
Lottery?
Lottery. I don't know if that kind of sounds more like an American word. Like American word, maybe something like rotary, but I think in America they call it a traffic circle. I think so. Yeah. Or no, a traffic control circle or something like that. Yeah. It's roundabout. Yeah. Okay.
One roundabout and then one more thing, like it's a U-turn.
U-turn circle. Yeah. Now, it takes 5 seconds and the radius is 6. So the driver is going around a roundabout and the radius is 5 meters. Sorry, the radius is 6 meters. No thanks. I need to get it. And it takes 5 seconds. And it goes around in 5 seconds. And my question is, what is the V? Okay, so what information do I know? I know the T and the R. Now, yeah, we need the omega. So we can get the F, can't we? The F is 1 over 5, so equals 0.2 hertz.
So we will multiply 0.2 with 6. Yes?
No, not yet. We need to get the omega. So you have T equals 2 pi over omega. So omega equals 2 pi over T. So omega is
2 pi
2 pi over 0.2 T. Yeah. Oh, I guess I didn't need to get the F. I didn't need it,
Yeah, we don't need this.
1.047 radians per second. Yeah, and then finally, V equals omega or, so the answer now will be V equals, multiply this by 6.
0.5 meters.
I got 6.28 meters per second.
Okay. 2.05 is 1.25.
Why did you
Mhm.
wrote rad?
Mhm.
Wait, what?
Wrote.
Wrote
Wrote what?
radius.
2 pi over 5, yeah?
Oh, here?
Yeah.
Is 1.25.
No. The unit in the ohmic line.
6.
Oh, this is the unit, radians per second for omega. This is the unit for it.
But you said the
Yeah.
rad is not free unit or free dimension.
Yeah.
Ah, yeah, so like, if you don't write it, that's okay.
It's
7.52.
Are you sure?
Oh, no.
What
The
happened?
time is 1 upon S.
No.
Why
Time
are-
is 5 seconds.
Yeah.
Oh, sorry, thank you.
It's 7.5.
Wait, so, what did it, V equals omega or?
The omega is wrong here, right?
Ah, the omega's wrong. Sorry, because I used 6.
Yeah, you 6 instead of
Yeah,
5.
thank you. 2 pi over 5. Yeah, sorry, that should be 1.26
Yeah.
radians per second. So then the V is omega or
1.26
times
times 6.
6, yeah. Thank you, this is what you said a moment ago, 7.54 meters per second. And this is using V equals omega or. So this is what was given in the question. Okay. Can we go to the next one? Yeah. Yeah. Continue?
Why we have to calculate F?
We don't. That's what he said. So it's a good question. Why do we? We don't. Yeah. Okay. Continue.
Yeah.
Yep. Okay. Right. Again, I want you to read this and then draw or write it. A 10,000 kg plane is banking and takes 1 minute to circle a path of radius 1 kilometer. So do you know this word banking?
No.
So when you see the plane, it's flying like this, and then
coming down.
this is called banking.
Okay.
When it turns.
When
When-
falls down.
No, watch. Listen. This is the plane, and banking is when one side goes down,
Oh.
so it can turn.
Yeah.
So this is banking. Yeah.
10,000 divided by.
So this is banking. Now, write or draw.
Why does it go down?
The plane.
Yeah.
I think that's a question we'll look at later, actually. Yeah. Did you draw?
It's a big answer, I think.
I think it probably should be because the plane is so big.
It's 16666.
Let's try it. Did you draw this, Adnan?
First we find the acceleration. Acceleration is 1
Say again?
newton upon 6
Yes?
1 minute. So like we will do like this.
Yeah.
1,000
What did you draw?
equal to 1 kilometer. And then divided by 60.
1 minute, yeah.
1 minute.
And then this here is 1 km.
Then you multiply by the mass.
Okay, guys, look, we're going to do this one now. So I'll try and draw this, give you a sense of perspective. So this is the air here, and this is the ground. So what's happening is the plane is basically just flying in a circle in the air. So planes usually planes usually do this when they're waiting to land at the airport. So they bank and circle the airport until they have permission to come down and land. So I tell you the T equals 1 minute. That's 60 seconds. And I also give you the radius, 1,000 meters. So the plane is going around in a circle. So as the plane goes around, which way is the force? To the center. Yeah. Okay. So I want to calculate the F. What does Newton tell us the F is? MA. So I need to calculate the A. Do I have a formula to calculate A? I do, yeah. So let's see what we can make. Newton says F equals MA. Do I know the M? I do. It's 10,000 kilograms. So the F will be 10,000 A. Now, do I have a formula for A?
Yeah.
I do. What is it?
It's
V squared over R. Now, do I know the R?
Yes.
Yeah, I do. What is it?
1,000.
1,000. So now this will equal 10 V squared. Now, do I know the V? I don't, but do I have a formula for V?
Omega R.
Yeah, V is omega R squared. Now, do I know the R?
Yeah.
I do. It's 1,000 omega squared.
Why omega R?
Why is omega R?
I think omega
V equals omega R.
R.
Yeah,
That's the formula.
yeah.
what is
We're getting there. 1, 2, 3, 4, 5, 6, 7. So there's only one thing left to calculate, and that's the omega. Now, you remember you have this formula for omega. Omega equals 2 pi over t. So if I just put in 2 pi, and what's the t? 60.
That's 0.10. 0.1.
The inside part, is it?
Sorry.
Oh, you give me the final
I
answer?
just
No.
got the omega, sorry.
Oh, no, that's okay. That's let me just put it. Whoa.
No.
109,663 newtons, or if you want, that's 110 kilonewtons. So that's how big the F is to keep this plane moving in a 1 kilometer circle. Now, I maybe made this a bit longer than I need to. If you wanted to, you could have calculated these things on the side, you know, and then put them directly in.
Yeah.
Which maybe I'll do it that way next time. Okay. But can you see that they're not really that difficult? You're just using the 4 formulas. That's all. I mean, in some ways I think it's even easier than the UBATS because you have
Clear.
there's less choices you have to make because often there's only one formula you can use. Okay, can we continue? Yeah.
I'm doing this. Yeah.
Okay. Write or draw this one. So we have 2 more examples to do. For long.
Huh?
I'll pick on you. So do you know this verb, swings? You do? Show me.
Right.
Yeah. It's a verb and it's a noun. Yeah. So I think last time we used it as a noun. As a noun, it's this. That's as a noun. Do you know what it is as a verb? No. As a verb, it means to turn, to spin it like this. Like, I don't have anything. I suppose like this. Yeah. So this is it as a verb. Yeah. So the boy swings 1 kilogram around in a circle of 2 meters at a speed of, at a rate of 2 hertz. How fast is the object moving?
The linear velocity will find, or the angular?
That's true, actually. I didn't specify which. If not specified, I think linear is what you should naturally assume. Okay. Can I do this one?
Yeah.
Right, so what you have is the boy is swinging around in a vertical circle. So I'll just put his hand in here. And then here's the rope, the string. And let's say it's going around like this. Spinning it around. Yeah? What information do I tell you? I give you the frequency. What is it? 2 hertz. And what else do I tell you?
1 kilogram.
The mass I tell you is 1 kilogram. And the radius is 2 meters. And what do I want? I want the V, which equals omega r. So before I can get this, I need to know the omega. So what formula gives me omega? Omega equals 2 pi over t. Do I know the t? No. So before I can do this, I need to know what the t is.
0.5.
So the t equals 1 over f, which equals 0.5 seconds. The omega equals 2 pi over t, which should be 4 pi, is it?
Yeah, it's 4 pi. 12.5.
Which is, we'll move on, 12.57 radians per second. And then finally, I can get the V, which is omega r times 2, which is 25.1 meters per second. So that's how fast it's spinning here. Its speed is 25.1 meters per second. And you'll notice that you didn't need the m here.
Yeah.
But again, I'm just using the usual formulas here. Okay, last one now. I'd like to see what you draw for it, to read it carefully. Continue? Okay, so a ball rolls inside a sphere of radius 5 meters, forming a circle of radius 4 meters. What is the velocity of this ball? So I want to see what the heck you draw for this. What's a sphere? Sphere is a ball.
Ball. Circle.
Like a football.
Yeah.
It's a round shape like this.
Like the first
Yeah. Valence shell. First valence shell is a sphere.
Yes. N equals 1. Sphere. S. Yeah. S. S. First sphere. Sphere.
Is that the ground state?
What?
The lowest state?
Yeah.
Like hydrogen, 1 proton, 1 electron. N equals 1 is the lowest orbit.
The S is the sphere.
It's not the sphere, it's the shell. S is the shell.
So it's a sphere.
Yeah, it's basically a sphere. But then there is P.
Don't think
P
it's-
is also the sphere.
The P is not a sphere.
What?
It's
The P is not
the
the
peanut.
sphere.
Yes.
Oh, yeah, you were talking about this.
Yeah.
Talking about
Yeah, I know what he's talking about. Yeah.
So you
Okay.
don't even know, but you have to come in.
No,
Some people are just like this. Okay, draw this. I want to see what you draw. Did you draw something?
inside a sphere.
I want to see what you try to draw here. Put in the numbers, the 5 and the 4. I want to see where you put them in. Andy, what did you draw? Not bad, but not right. What did you draw? Ah, not bad, but not right. Let's see. Nope. Okay, I draw it now. Yeah.
Like
Is
it.
it like this?
Like it.
Nope.
Like it.
That's this one.
Now we might be getting closer to it now. Show me where the 5 and
The
the
ball
4 is.
inside.
Show me.
The 4.
Like this.
The small circle inside the big circle.
No.
That's 4.
You know, but draw the 5 and the 4 in. Let's see what you're thinking.
This is 4 and this is 5.
Yeah, that's it. Good. So, one person got it. That's
It's sliding, yeah?
which one? Which one are you pointing to? Nope, not this one. Right, so what you have this big sphere, and its radius is 5. And everybody got this.
Yeah.
But what's happening is there's a ball here that's rolling around on the inside. And this is 4.
Oh.
This is like at the circus.
This is like 3D.
Yeah. So it's 3D, so I'll just look at it straight on. So if I look at it straight on, the ball is going around like this, isn't it? If you can imagine that it's coming closer to your face as it goes around like this. So, how big is it from here to here?
2.
No.
Yeah.
4.
Yeah, it's still 4. This is 4 and this is 4. Yeah? Okay. So this is 4 meters here. Now, if I draw a line straight down, that's supposed to be in the center. How big is this?
5.
That's 5, isn't it? How big is this, if I put it in green? Here to here?
4.
5.
5. And if this is 4, then this is 3. So let me zoom in on the ball, okay? So if I zoom in on the ball, here's the ball, and here's the wall. And how many forces are here? There's only 2 forces.
Why? Reaction force?
There's the gravity,
And the reaction.
mg, and then the reaction force here. The angle of this is this angle here. Because this force points to the center. Yeah? So, theta equals tan inverse 3 over 4, which equals,
36.9.
it's like a classic one now at this point, I've used it so many times, 36.9 degrees. So here, this will be or cos, and this will be or sine. So what is the cos of this angle? 4 over 5.
Yeah.
So this is 4/5 or, and here this is sine or sine, which will be 3/5 or. Okay, so I'll continue, but I'll just give you a chance to get this down. Okay. Yes? Okay. So look, when the ball is going around like this, is it moving up or down?
Up.
Is it moving up or down?
Down.
No. It's keeping the same height as it moves around. So that means 3/5 or should equal mg. That the up force equals the down force. So then the or equals 5/3 mg. That's one useful result. So I can put that in here. And this will be 4/5 5/3 mg, which will be 4/3 mg. Now, so my question now is, what on earth is this force? Does it equal anything here? No. Should it? What do you think?
Maybe it simply equals.
No? So what's the deal here with this force?
Equals F, that's going to the center.
Yeah, if you look at this now, if you look at this from the top, you'll see the ball going around.
Yeah.
That force here, this force, which is this force, that is the force that's going to the center. In other words, this is the centripetal force. This is the centripetal force. So we have F equals ma, 4 over 3 mg equals ma. Cancel the m's. So A equals 4 over 3 g. If this is the centripetal force, this one is the centripetal acceleration. Do we have a formula for that? We do. V squared over r.
Yeah.
So now we get v squared over r equals 4 over 3 g. Now, what is the r?
5,
Is it 4 or is it 5?
5.
4, because it's the radius of the circle it moves in. So v squared over 4 equals 4 over 3g. So now I can finish by getting the v.
Why did we... Oh, yeah.
Is okay?
Yeah.
7.23 meters per second. So this is how fast the ball is moving. Now look, you sometimes see these in the circus. You have a giant metal sphere, and inside it is someone on a motorbike, and they're going around it.
Yes.
Yeah? So in this example, if this was a person on a motorbike, if they went at this speed, they would stay in the circle. If they went faster, what would happen?
Up and down.
They would move, mostly moving up. And if they slowed down,
They will fall.
they'd move down. Yeah. So, like what we were saying earlier, to get this motion in a circle, not only do you need the force in the center, but the speed is important here. Yeah. So, in fact, if this is moving in a circle, it must be doing it at this speed. Otherwise, there's a problem. More than this speed, it's starting to expand the circle, and less than the speed, the circle shrinks down, and basically he falls down then. Yeah. So the v can't just be anything. It has to be a very particular value here. Yeah.
But like if I'm in the, like I get the idea, but like if I'm in the car and I turn the steering,
Yeah. Yeah.
like I still go the same direction.
Well,
Like if I'm on the car
yeah.
and I turn like the
Yeah.
steering wheel,
Yeah.
let's say like 30 degrees.
Yes.
If I move like fast
Yeah.
and it's 30 degrees,
Yeah.
it will be like more of a curve.
Yeah. You'll take a bigger turn. Yeah.
If you're going faster.
You're going faster. Yeah.
Yeah.
But like the wheel is on one certain direction.
True.
Yeah, so why does it change the speed?
Yes, there is.
It does change.
You go slow, you can go like this. You go fast, you go like this.
Like a drift,
No one's drifting.
We're just talking.
You got a bicycle. Have you got a bicycle?
Here?
Yeah, you can bring your bicycle to school. You can test it out. I know what you're saying because the wheel is pointing the same way, but it gets a bit complicated because your ability to turn the wheel depends on how fast you're going as well. You know, like for example.
Ah, I got your point.
Yeah, I think if you're going fast, it's probably easier to turn the wheel than if you're going slow. For example, if you're parked. No, like think about this. If your car is parked and you want to turn the wheel, that's much harder to do than if you're going fast on a motorway. Because if you're parked and you're not moving, when you turn the wheel, you can hear it going on the ground. It's harder to turn. So I think what's complicating your understanding is that the difficulty in turning the wheel. So when you're going fast, it's easier to turn the wheel. No?
But if it's easier to turn the wheel, that should mean that.
Yeah, but never. I remember I said I'm only talking about how much force is going in the center, not how much the wheel is pointed.
No. Either
Yeah.
way, the speed is kind of like pushing the car to the front.
I
Not just turning to the left, going northwest.
We don't have to discuss it, but
no, we're finished here. But I know what you're saying. It depends which ways these are pointed.
yes.
Yes, yeah, but it gets a little bit complicated because the force that's going towards the center here will come from the wheels,
Okay.
Yeah.
and these wheels, the reason they have a force is because the tire rubs against the ground,
Yeah.
Okay.
and this makes a force here. But this force depends on how much friction there is, and that depends on how fast the wheel is turning. So for example, if the car is going very fast, then you will only need to turn it a little bit to make the same amount of force going in. If the car is going very slow, then you might have to turn the wheel more to get the same amount of force.
Because there's no friction.
Yeah, because the friction changes because, friction, you get more of it as it rubs more, So the reason it gets a bit messy here. So when we talk about our cars going around a roundabout, we never think about the wheels and just imagine a magic force coming out the side of the car perfectly. Like magic.
We'll buy a new car and then
This
we'll
makes sense.
This one, Right, I'll put the questions up. Okay.
So this is our homework.
Yeah.
Okay. So better than I take pictures.
I'll put the video up today. The homework, you mean? Yeah. That you missed because you were at the court talk. Yeah. I'll put the video on YouTube today.
Yeah, but even
What's
all
the
the homework, I don't see
It is on YouTube.
what's
I'll show you.
the difference in-
Give me your phone.
I don't see the lesson.
That's it.
I'll show you.